everyone, welcome to today's video. We're going to explore an important machine learning algorithm called the naive Bayes theorem. This algorithm is widely used for classification tasks like spam detection, sentiment analysis, and more. In this video, we'll dive into the fundamentals of naive Bayes, go over its working principle, and demonstrate its application using Python. If you're ready, let's get started. First, let's define naive Bayes. Naive Bayes is a probabilistic algorithm based on Bayes' theorem. It assumes that all features in the data are independent of one another. This is where the term naive comes from. The theorem states P A by B is equal to P B by A into P A upon P B. Here, P A by B is the probability of class A given evidence B. P B by A is the probability of evidence B given class A. PA is the prior probability of class A and PB is the prior probability of evidence B. This formula forms the backbone of the naive Bayes algorithm, allowing it to classify data based on conditional probabilities. How does it work? Let's take a moment to understand how naive Bayes works step by step. Calculate priors. First, the algorithm calculates the prior probabilities for each class. Likelihood estimation. Next, it computes the likelihood of each feature given each class. Apply Bayes' theorem. Using Bayes' formula, it calculates the posterior probabilities for each class based on the input features. Classification. Finally, the algorithm assigns the data point to the class with the highest posterior probability. This simplicity makes naive Bayes computationally efficient and suitable for large data sets. Python implementation of the naive Bayes. Now, let's implement naive Bayes in Python using the famous IRIS dataset. We'll use the Gaussian NB model from the scikit-learn, which is ideal for continuous data. Here's the code that we'll use. Let's break this down. Dataset. We start by loading the iris dataset, which contains features like sepal and petal dimensions for 3 flower species. Train test split. Next, we split the data into training and test sets using train test split, allocating 70% for training and 30% for testing. Model initialization. We create an instance of Gaussian NB, which is designed for continuous features assuming a Gaussian distribution. Training. The fit method trains the model using the training data. And prediction. We then use the predict method to classify the test data. Evaluation. Finally, we evaluate the model's performance using accuracy and a classification report, which provides detailed metrics like precision, recall, and F1 score for each class. Now, let's look at the output you can expect when you run this code. The accuracy is around 98%, which is quite good for this dataset. The classification report shows the precision, recall, and F1 score for each class, helping us understand how well the model performs across all flower types. Now, let's quickly cover the pros and cons of naive Bayes. It is simple to implement and computationally efficient. It works well with small data sets and is effective for high-dimensional data. It performs exceptionally well for text-based classification problems like spam detection. The cons include, as assumes feature independence, which isn't always realistic, may struggle with continuous data unless distributions are well suited to the Gaussian assumption. Finally, let's talk about where naive Bayes is used in the real world. Spam filtering. Email services use naive Bayes to classify emails as spam or non-spam. Sentiment analysis. It's used to classify reviews or tweets as positive, negative, or neutral. Medical diagnosis. helps predict the likelihood of diseases based on symptoms. Text classification, it is widely used in news categorization and topic modeling. That's a wrap on today's video. We explored Naive Bayes, its working principle, a Python implementation, and its real world applications. If you found this video helpful, please give it a thumbs up, subscribe to the channel, and hit the bell icon to stay updated. Let me know in the comments if you have any questions or suggestions for future topics. Thanks for watching and see you in the next video.